Hadoop is this giant system that gives us two services in the game: store, process. And what it consumes is big data. So it takes all my big data, it lets me store the data, and it lets me process the data. It lets me store the data and lets me process the data. So this is exactly what Hadoop is all about. Can let you store the data and let you process the data. Okay. So here we'll take a small pause, and any question that you have so far in the session, please bring it up to me before I move to the next topic, because now we are diving into the topic. So now we will talk about how storage works, how processing works, how yarn works, and how MapReduce will work. So before I proceed, I'm all here. Any questions that you have, let's take them up.
Yes. Hi. Hi, Ravi. Good morning. How are you?
Good, Kailash. How about you?
I'm good. Thank you. I have a quick question. I was reviewing yesterday's session about the name node, and from what I understand, Mr. Mani explained, is name node is more of like an in-memory store where it stores the files and block information so that it can pass it on to the data node to store and retrieve the data. But my question is, suppose you configure a memory storage for a name node, and if a huge file comes the next day to be stored, how does name node allocate memory? Is it like a dynamic, or it fails when sufficient memory is not available?
Okay, so great question, but then that we'll have to wait for just another 10 minutes to answer that, because that's what exactly we'll get into. So your question is absolutely legitimate, just that it's like two steps ahead of the thing right now. So just be with me for 10 minutes, we'll get answered.
No problem. Yeah, sure.
Yeah.
Thank you.
Sure. Yeah, any other questions, guys? Please come up and let's be clear on this.
Okay, so I'll take up the question only for the things that we have discussed. So I think many of the questions are related to the architecture. So in the next 10 minutes, once we finish the architecture, then we'll take up all the questions. And one question is, what are the other tools in the Hadoop from Abraham?
Yes, I'll be answering that. So that will be covered in the next diagram. Yeah.
Okay.
So other tools and the architecture part. So while I'll go with this. So guys, the first thing, the only thing I want you to remember right now is, as of now, is Hadoop is this giant system that says, okay, bring in the data, I will store it for you, and I will process it for you. Bring in the data, I'll store it for you and process. If I was a student, probably I would have this question right now in my mind, that probably so these are really two questions that will haunt me right now, that, okay, you're telling about Hadoop is some system that will give me storage and processing. How does store really work and how does process really work? So let's get into that right now. Let's get into that. So there are two questions that as a student probably will come to my head, that, okay, yeah, he's talking about Hadoop is some system which is store and process. Okay, cool. How does store really work? How does process really work? If these two questions get answered, then I'll be probably clear that what Hadoop is all about. So I'm using some imaginary name. So let's say we are TCS, Tama Consultancy Services. Forgive the spelling. And we have presence in 150 countries, and let's say people love us. Just yesterday, our Facebook page got 1 billion likes. So our Facebook page has got 1 billion likes. Okay. Sorry, Kailash, I'm borrowing your name. Okay. So let's build this story, guys. Focus on the story, because once you get the story right, this all questions about, oh, name, node, this, then everything will get very, very clear. Focus on the real story. Just focus on the story. So we are Kama Consultancy Services. We have presence in 150 countries. People love us. We've got 1 billion likes on Facebook. Our CEO, Mr. Kailash, is really excited and wants to see a very huge dashboard where he sees whole globe. And based on hovering on each country, he will see the number of likes. Okay. So in 4 days' time, Ajay is supposed to get this dashboard made. So now what happens is, let's say Ajay wants to use Hadoop for this. Let's just say that. So Ajay has two members in his team, Mr. Admin and Mr. Developer. Now Ajay tells Mr. Admin that, dude, go set up Hadoop cluster. And he tells Mr. Developer that, listen, you are supposed to develop this whole dashboard. Okay. So let's see what happens right now. Let's see what happens right now. So now the story begins. Ajay has two people in his team, and those two guys are now starting to do the business, or they are getting about business. So let's see what does. So first, admin comes in, and admin purchases 5 machines. Admin purchases 5 machines. Okay. Where admin decides one will be master and 4 will be slaves. So Mr. Administrator has come to work and he's setting up a 5 node cluster, 1 master and 4 slaves. And Hadoop is all about storage and processing. So on the master, he installs somebody called as storage master. And on the master, he again installs processing master. Okay. Now, on the slave, he installs storage slave, and he installs processing slave on the processing master, a processing slave. So on all slaves, he's installing this. Now, admin tells Ajay, boss, setup is done. Go ahead, ingest data and write program. So now Ajay calls Mr. Developer and says, Mr. Developer, go ahead and please write the code. So first, developer has the code data. So developer takes data, which is let's say facebook.json, and let's just say that the file is 640 MB. Let's just say file is 640 MB. So when it writes to storage master, actually the file is broken into blocks of 128 MB. So 648 divided by 128 means 5 blocks, and each block is replicated 3 times. That means 15 blocks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Let me write the calculations. I'm sure you already know about it because you did a session yesterday. So 128 MB is each block, and 3 is the replication factor. Okay. Now the data is already broken into it, and the storage master actually just has the metadata. The metadata looks just like Facebook.json is nothing but block 1, 2, 3, 4, 5. Let me change the color here. So the metadata would look like Facebook.json is block 1, 2, 3, 4, 5. Block 1 is present on slave 1, 2, 3. Block 2 is present on slave 2, 3, 4, blah, blah, blah. So this is what is stored in storage master. Now to answer your question, Kailash, there is no problem of memory because master is storing only the metadata, not the data. And when the data is getting transferred also, data is not passing through the master. The client will directly connect to the slave. Now, because of that, the memory is not at all an issue. Because of that, the memory is not at all an issue. That's the real idea. That's the real idea. So, irrespective of how big file you write, okay, it just goes through, just has uses the memory of name node for the metadata, but the data is returned to the what you call slave. Now, let me just give you a simple example around this. Let's just say there is a project manager who has 4 people in his team. Now, project manager just knows what tasks people are doing, but all the tasks are done by the slaves. So that's why manager is not a bottleneck. Neither is his capacity to know which task is running where is a problem because he's just knowing what is running where or what is stored where. It's not about doing it. So manager is doing nothing in this. He has the metadata. That's the idea. Okay. Now your data is stored. So developer took the data, he writes to storage layer, and all the data is spread across and done. Now the developer writes the program. And because we want by country, let's say it is group by Java program. Let's not complexify it, just it's a Java program. Now this Java program gets submitted. The processing master will copy this code on every machine. And that's internal, so it's not our business how it's done because it's a framework. So you submit to the master, master will push it to everybody. Now what master will decide is master will tell that, okay, listen up, Mr. Four Slaves. Slave 1, you process block 1 and 2, which is local to you. Okay. Slave 2, you process block 3, which is local to you. Slave 4 or slave 3, you process block 4, which is local to you. Slave 4 process block 5, which is local to you. So do your business locally, don't talk to the network, and the job has to be done. And then you get your final output, which can then be, directly shown on a reporting tool, or you can load it to a warehouse and show the whole thing. Now, this is how Hadoop really works. This is how Hadoop really works. Okay. Now, don't worry about the process names. That will come in the next slide. Right now, just focus on the concept. The concept is simple. Write data, cut into pieces, spread it across. Write the program, spread it across, and do it locally. That's about it. That is how Hadoop really works. That is how Hadoop really works. So this is Hadoop for you. This is Hadoop for you. Now let's quickly get into the process names, because once we get the concept right, it's about understanding the process names. Okay. So guys, before I proceed, the next diagram I'm going to draw is the most important diagram of this session. So please get this right, because this is, you can say, heart and soul of the whole session. So make sure you get this explanation right. After this slide or diagram, we will pause for 10 odd minutes to take any questions that you have. But this diagram is very, very pivotal. Tighten your seat belts. You got to get this diagram right. Okay. So far, let's say the trainer has been talking about Hadoop gives you two services: storage and processing. Wow. Now let's get into names. The team that gives you storage is called as Mr. HDFS. The team that gets you or lets you do storage is called as Mr. HDFS. This is the team that lets you do storage. The team that lets you do processing is called as MapReduce. Now, again, it's a master slave. So the master in HDFS is called as name node, and the slave is called as data node. In MapReduce, the master is called as job tracker, and the slave is called as task tracker. Simple stuff. So storage, the processes are HDFS. The team is called HDFS and has two processes: data node and name node. For processing, it is job tracker and task tracker. So life is very, very simple here. Good. Now, this particular setup had one very serious limitation. This particular setup had one serious limitation. So this setup was called as Hadoop, good, but this had one serious limitation. You can only write programs in MapReduce. So whether you like it or you don't like it, you will only have to write programs in MapReduce or any other framework that runs on MapReduce. But you can't have anything else. Take a simple example. You can't, let's say, use Spark for that matter. That's a limitation. Let's take another simple. Let's take a real world example. This will make it clear. So make sure you get my question right. Let's say I'm a layman. When I say layman, it's a proper layman. Okay. So let's not argue into technicalities. I'm just an ordinary Jack who runs, let's say, a burger shop or a coffee shop. Now, there is a problem in my iPhone battery. There is a problem in the battery of my iPhone. Can I just buy a new battery and put it in iPhone? Can a normal person walk into the store and buy battery for iPhone, open iPhone, plug it in, and it's done? No, it's not. Why? Because Apple tells you that, listen, if you want to use my phone, you will have to use my battery. You like it or you don't like it. You can't take any other battery from the market and plug it into iPhone. Very similarly, if you wanted to use Hadoop, Hadoop would say, listen, you're welcome. Come use it. But you'll have to express yourself in MapReduce only. That was a serious limitation. That is why it was called as Hadoop 1.x. It was called as Hadoop 1.x. What you really wanted is something better. What you wanted it is generalizing it. So that's where I decided to come with another version of Hadoop where we had storage, which was same. But instead of MapReduce, you bring a new component called as Yarn, which is nothing but resource manager and node manager. Now what Yarn would do is, it says I will give resources to anybody. I can give resources to anybody. So be it MapReduce and be it Spark or be it, doesn't really matter. Okay? Doesn't really matter. What happens right now is, with Yarn, if I was to put in one word in Hadoop 1.x, but in 2.x, so guys, the keyword here is, all I want you to remember is, in 1.x, MapReduce is the only way. In 2.x, MapReduce is one of the way. It is one of the way. Now, this course is all about 2.x. We are not discussing 1.x here at all. Now, the reason I explained you 1.x is like, can I explain good health without explaining bad health? Probably it's going to be tough. Very similarly, if I have to explain 2.x, I should first show you 1.x and the serious limitation there, and that's where you bring in 2.x. That's where you bring in 2.x. So 2.x is a generic uh, resource manager which says everybody who needs resources, come, I'll give you the resources so that you can do the job. So that you can do the job. That is how 2.x really works. Okay. So this is Hadoop 2.x. Now we'll do one more slide, one small slide, and we will go ahead and take up the questions. So now we'll introduce other components, but right now you got to get this one right, that why yarn is there. How does this diagram change? How does this diagram change with 2.x? So I'm going to remove everything that is there and we'll slowly put one by one because you've got to understand this. So right now there is nothing. I just have storage layer. Okay. Now here we will have yarn master, which is called resource manager. Don't worry too much about names because you will eventually, once you're out of this course, you'll be a champion at this name. So you don't have to really worry about, don't clog your head with too many names right now. Just keep it simple. Keep your life simple. That will be good right now. Just understand, okay, there is yarn master and yarn slave. So you're not going to a war tomorrow morning that you should remember all the terms. So there is storage master and storage slave, and there is yarn master and yarn slave. But I have not added anything else. So there is yarn master and yarn slave. The names are resource manager and node manager, but don't worry too much about them. They are somebody, it's fine. You'll figure this out. So my storage layer remains same. I write my data, it is processed, all that is fine. But when I submit my job, to yarn master, yarn says, so let's say this is a MapReduce job. Yarn says that, hey man, I don't know how to run MapReduce, but I know a guy who's called App Master. Okay, he can do MapReduce for me. So I am the resource manager. I only give resources to people. So I don't understand how to do processing. But I know another guy called App Master. He will do the job. So now Yarn will initialize an App Master on any one slave. So let's say Yarn will initialize an App Master here. App Master is a process that will do the job. So who's responsible for the job? It's MR App Master, not Yarn Master. So Yarn Master says, oh, Mr. MR App Master, there is a new job for you. Why don't you do it? So now app master will go to yarn master and say, boss, if you want me to do this job for you, if you want me to pull this job for you, please give me following things. Give me 2 resources on slave 1, 1 resource on slave 2, 1 resource on slave 3, and 1 resource on slave 4. Why? Because data locality is important. So yarn master says, okay, go ahead, take the resources, and MR app master will now go ahead and fire the job everywhere. Like this, if you submit another job, there'll be another app master who will do the job. So the idea here is that yarn master does not do the job. It only gives resources. MapReduce can ask for resources. Spark can ask for resources. Impala can ask for resources. Anybody can ask for resources, and you are good enough, or you are ready to just go ahead and do that. That's the real idea. So this is yarn for you. And that one keyword is in 1.x, MapReduce is the only way. In 2.x, MapReduce is one of them. Why do you need to go for 2.x? Because you want more options in life. Simple as that. Simple as that. If you think of it, I'll give you a simple example of this company called Food Panda. This company called Food Panda. So Food Panda is a company that does food delivery for you. Now, if you just go to Pizza Hut, you can only call Pizza Hut or McDonald's and get delivery only from McDonald's. But if you call Food Panda, you can basically order from any restaurant that you really like. So think of Yarn as Food Panda, who says, listen, I don't make food, but I can always provide delivery services for people to do what they want or have what they want. That's the real idea. That's the real idea. With this explanation, so I'm not introducing other components of Hadoop. With this explanation, our entire landscape of Hadoop from the architectural working perspective is done. Now, you are free to ask any questions that you have. So we are at like,
So let me go in there.
yeah, go ahead.
So let's talk about Shrikant. Shrikant, I have unmuted you.
Hi Ravi. In your in your first slide, you mentioned like the Hadoop as a big storage, and we are storing we can store the data from Oracle or different sources, and we can process and send the data back. So till now, my understanding from yesterday's Money's demo or my own Google stuff, I was in assumption like Hadoop is a what you can say like replacement or other alternate for this data warehousing and reporting tool. Uh, can you elaborate on that? Is it really an alternate or it's just a processing tool and which will send the data back to Oracle or data warehouse or reporting tools? That's my question.
Okay. So, okay. So let's kind of understand this from the first thing. Can I replace data warehouse completely with Hadoop? Well, it sounds to be very lucrative, but it's actually you will lose a lot of convenience of what a data warehouse will provide. All your data modeling, all your structure, the tools that are out there, they'll become unusable because Hadoop is a very raw system where you can store the files, you can create tables in Hadoop, yes, but that entire thing has to be managed by you. Okay, so there is no question of, let's say, referential integrity. There is no question of what do you call making sure that your data is the dimension models, the facts, everything has to be maintained by you. So a lot of companies, just not to disrupt the whole thing, they are using warehouse as first you process data in Hadoop and then load it in a warehouse. Okay. Now let's talk of a fresh thing. Okay. So let's say there is a company that does not have a warehouse today. Can they live or like do away with warehouse and directly put Hadoop? Yes, a lot of companies are already doing that. So what I'm trying to say is, if your company already has warehouse, a lot of companies, let's just say I work with 3 customers, what they do is they have Teradata in place, they've already paid for licenses and all. They use Hadoop as an area where they load all the data. Okay. So they'll basically do something like, ELT in Hadoop. So extract, load in Hadoop, transform it, and again load it back to a warehouse. So it's for you or it's for a company to today take a call. There is already one customer, one telecom company I know of, that they are already in process of, they've kind of disrupted their warehouse where they are removing Teradata and moving completely to Hadoop. So there are a lot of pains where the data modeling and everything is becoming very inconvenient, but they're okay with it because that saves them millions of dollars. So it's an open-ended question that with data warehouses, you get convenience of all that dimensional modeling, tooling, and all that, which is Hadoop is relatively young today. So, that's the real idea. So first thing, let's put it this way. If your company is already using a warehouse and Hadoop is introduced, the real suggestion from a lot of companies like Clouder and all is that use your warehouse as a staging or is the tool that after processing is done, you load it in a warehouse and do reporting. If you are absolutely fresh, you can do away with warehouse and put your Hadoop as itself a warehouse. No need to go for another warehouse. And now there are hybrid models also. Now, what is a hybrid model? Uh, Now, Teradata is not going to basically, sit idle around that. So what Teradata has come up with is a product called as Query Grid. Now, in Query Grid, the idea is that you run your query in Teradata, but without this being your business, the query will get fired on Teradata as well as Hadoop and merge the data for you. Okay, so it's a kind of confused landscape where if I was to quickly draw this for you, let's put it this way. Let's put it this way that you are a company with, let's say, no serious warehouse investment. Well, only Hadoop is definitely an option. If your company is already deep into warehouse, a lot of companies would transform in Hadoop and load data to warehouse. Okay, and now there are hybrid models. I know of one bank, they have decided they will not do away from Teradata because Teradata is way too deep into them. So they use product called as something like a query grid, where it's like fire your SQL and don't worry about data coming from Teradata or it's all hidden. So yeah, to be honest, there is no definite answer to this. So if I'm a startup today, I will definitely not invest in Teradata. That's how I'll put it. So does that answer your question, Srikanth?
Yes, yes, Ravi. Thank you.
Yeah. So where you are in the life cycle right now is very, very important because see, if you say, oh man, wow, I can do away with my investment of warehouse already. If you have a warehouse, boss, already so many developers are working. You can't one find it disrupted. So the telecom company I'm talking about, they're slowly phasing out, and eventually by 2017, and they'll be free from the warehousing. Tool licensing and maintenance cost and all that stuff. They'll just be Hadoop. But yeah, there are a lot of pains which will be coming to you. You'll have to be prepared for that. Yeah. Okay, so these are 3 options that you have today.
Yeah, thank you.
Okay, thanks. So we have a next question coming from Ibrahim.
On the Hadoop, but I have a question. When you're talking about the block, when we're making an assumption on the 640 MB with a block, you didn't even explain what a block is. And when you are splitting the slaves into 5, and then how do you come about this 5 slaves? And from the yarn perspective, that's what I'm talking about. The block, you're talking about 3 replication factor, that is understood. But how does the application manager, okay, fine, determine the sources and the slaves from the processing a yarn, my master?
Okay, so can I just put your question in something like, so I think probably this is what you're trying to ask, but let's kind of understand this. So let's say we have a file which is, just put any number that comes to my mind. Let's say
Okay.
333 MB. Okay.
Okay.
333 MB. Just an example. Okay. Now, can I say that with 333 MB, when HDFS will break that, it will break it as 128 plus 128 plus 44 plus 33 is 77 MB.
Is that a 128? Is it a default?
Yes, it is default and configurable. Yes.
You
So
cannot
that is
use, okay. As of Hadoop 2.0 right now, right?
Exactly.
Correct?
Yes.
So
it's
okay.
default and configurable. So now that's first part of the question.
So whatever the size of the inputs is just divided by the 128 to know how many slaves to be attributed to, right?
Absolutely. Now, there is another dimension to your question. Probably you didn't mean that, but I'll just cover that here because some of you will have this question. So let's say in this 133 MB, at one point, there is lot of, and at around 128 MB, the text is but you know what? I can't control, but at this moment, 128 MB was ending. At this moment, 128 MB was ending. That means this went to block 1 and this went to block 2. Okay. And in the block 2, the text looked like MOVS movie. The data was ending at, let's say, /n. And the next sentence in block 2 was, now what happens is by default, MapReduce framework will take care of making sure that, oh, the data is not ending properly. So while it is reading or processing, it will take the initiative of going till the very end and finding that /n, and this particular chunk will be processed by mapper1. Are we getting it?
Okay. I do.
Yeah, this initiative is taken care by the framework, so as a developer, you don't have to worry about that.
Okay.
Okay, that's that.
Okay. All right. Thank you.
And you said in the 2x we can either use whether we can process via MapReduce or Spark. I'd like to know what is Oracle? No, you said others. Yeah. What is the main difference between the MapReduce versus Spark, and why Spark? What's the advantage of using that? How is it different?
This course will cover Spark immensely, but let's answer this in the shortest form. But you will be having a lot of coverage in Spark during this course. But look at it this way, okay? MapReduce, when it was created, it was majorly using a lot of disk. Now, computation was already making a lot of advancements, and new frameworks were created which were, what we call very heavy on memory, which can use memory in a very, very big way. Let me just give an example. Let's say MapReduce came into picture in 2000. It's like now 11 years. So let's just say 2005. Around that time, MapReduce came into picture. Where the biggest server, 2006 maybe. Yeah. So the biggest server in the market with RAM would be, let's say, 64 GB or 128 GB. Okay. Nowadays, you have machines where you have RAM which is 512 GB also. So a lot of deployments where we have RAM which is 512 GB. So you can have more computing or more memory on machines. So that's where framework like Spark was created, assuming that we have a lot of memory. So let's utilize a lot of memory while we do processing. So MapReduce, when it was designed with the perspective that, oh, you know what, memory is not enough, so let's use a lot of disk. Wherever when Spark was getting created, that limitation was kind of not there, and the framework was created with more flexibility that we can use more RAM than what it was. It is exactly that way. So Spark and MapReduce, think of it, the fundamental way of processing is more or less same, just that MapReduce heavily uses disk, wherever Spark heavily uses memory. That's right.
Okay. Yep, got it. Thank you.
Okay, so the next person is Kailashnath. Kailashnath.
Hi, I have a question. I actually was looking at Mr. Mani's presentation yesterday for the name node, and most of the documents, what they say, wherever I read, they say that Hadoop version 1.6 was 1.x was only having one node, which was a single point of failure. Was it purposefully done to have only one master node to run the name node, or was like any limitation that caused name node to be run just only on one node? Because Hadoop is so data intensive. So designing with one name node was, I don't know what was the purpose behind having just one node, knowing that it's a single point of failure and we run on commodity hardware.
No, I guess that's not the message that's there. Thing is that you have one name node, and
Okay.
the other name node is for. So there are two concepts. Let's carefully understand so that we get this right. Let me just put this here. Okay, sorry, put this here. Okay. So this is name node, and then you can protect the name node with a
Secondary name.
There are two. One is secondary, and now in high availability you have standby name node. Okay.
Okay.
Now this is highly available. This is highly available. That means one goes down and other takes over. Okay. That's the idea. Are we clear with this right now? Now,
Yes.
Before I proceed, first question. Is this still one name node or there are two name nodes in terms of functioning? Technically, you still have how many name nodes? One. Other is a failover, correct?
Correct.
Yeah. Now let's see that if you really look at 1.x or let's say previous Hadoop, instead of standby, there was a name node called as secondary name node.
Right.
So now secondary name node one goes down and other cannot take over. It's just a backup, and this was called as secondary name node.
Okay.
Correct. Now let's kind of understand this. Now this is a story which is irrelevant, but let me just give you that background. See, every software evolves, right? So in the beginning, when Hadoop came up, this high availability was not a burning topic. It was not a burning topic. Then one provider of Hadoop, that company is called MapR. MapR said that, listen, we have a Hadoop which is better than yours because we have a name node kind of a concept, but we have multiple name nodes, so that name node will never go down. And that's what pushed community of Hadoop to come up with high availability. So the background of the whole story is that first, when Hadoop was there, having high availability for name node was, let's say, priority number 10 for them. They were already fighting with other features, correct? But then when MapR comes to the game and says, you know what, our Hadoop will never go down because we have multiple name node kind of they call that name node as CLDB. So they said, we have multiple CLDBs, so technically it will never go wrong. And that was a unique selling point, and that's where community quickly pushed on to the high availability part of it, and the priority 10 becomes priority 1, and that's what it came into picture. Now that's one thing. Now, just to clear a concept, I don't know if it's mentioned anywhere in the previous slide, but this is not true. I can have high availability in both Hadoop 1.x and 2.x, and I can have non-high availability in 1.x and 2.x. So 1.x and 2.x have nothing to do with high availability. What I'm trying to say is, I'm just giving you a clear example of this so that this is in your mind. This stays here. Let's say one of the biggest bank in Australia, they have still not moved to 2.x. They are still using 1.x because somewhere around 17,000 jobs and programs are running on that. Okay. Now they don't want to migrate so soon, but they still want Namenode to be highly available. So those guys are using 1.x perfectly fine and they are still highly available. So high availability has nothing to do with 2.x. I hope that is clear because this should stay that if you work at a customer location who's using 1.x, oh, please don't have this limitation in mind. Oh man, I'm using 1.x, so I can't be highly available. Of course, you can be highly available, and make sure you make your customer highly available because that's very important.
So how do you make that 1.x highly available by configuring Namenode in multiple?
Yeah. Exactly. So there is a process for it where you shut down secondary Namenode and start a standby Namenode. So there is a proper documentation you will find, but that's very easy. It's not that difficult. So the steps are out there, but sometimes a lot of people may have this confusion on that. Oh man, my customer is using 1.x, so he can never be highly available. Well, that's not true. Uh, the case studies, biggest bank in what you call Australia, they don't want to move to 2.x. They say, listen, boss, another 18 months we will be on MapReduce. We don't want to bring Spark, but they are still highly available, and it is perfectly okay with that. So make sure that that limitation is, if your customer is not highly available, make him highly available. Even if it's 1.x, tell him, boss, it's possible. You'll easily find the documentation steps. There'll be a couple of hours of downtime where you're making high availability enabled, and bang, you're back in business.
Okay. Okay. Thank you. Yeah, that clears.
Can you go back to your slide when you explained the 2.x in regards to Yarn Master? Yeah, here. Can you just explain me again, like 2 minutes? Yeah, that's the slide.
Not a problem. So let's take a simple example. So before I move to this explanation, let's reiterate one part. Guys, one thing before I re-explain this, let's make sure you have this in your mind. Like night 2 o'clock also, you should have this in the mind while you're in sleep. In 1.x, MapReduce is the only way, and in 2.x, MapReduce is one of the way. That means Yarn is a guy who says, listen, I don't understand processing. I will only give you resources. Whoever wants resources, you are welcome. Please come and ask me. I'll give you resources. Now that is first thing that has to be clear. So Yarn, master and slave, they say, listen, we don't understand processing at all. So when you submit a MapReduce job, Yarn will basically have references for MapReduce and Spark and anybody who needs resources. So Yarn master will look at the job and say, oh, this is MapReduce job. Let me call the manager for MapReduce, who's called MapReduce App Master. So Yarn master will fire the app master on any one machine and ask the app master, Mr. App Master, this is a job for you, which is a MapReduce job. Tell me, what do you need from me so that I can give you and free up? So the app master says, listen, oh, there are 5 blocks in this particular file. So I would require, let's say, 5 slaves or 5 resources. Give me 2 resources on slave 1, give me 1 resource on slave 2, give me 1 resource on slave 3, and 1 resource on slave 4, and I should be able to do my job. So the Yarn master says, of course, take these resources, go do your business, and we are good to go. That's how it really works. Are we clear with this?
Yeah, yes. Yeah, sorry, I lost my audio.
No, not a problem. Not a problem. Yeah.
Thank you.
Absolutely. Sure.
Hi, Ravi. This is Nelly.
Yeah, hi.
And this is a beautiful explanation. I have just 2 questions on this. One is, you're talking about resources. So what resources are these?
Okay. Good question. So resources that anyways we'll be covering in a slide, but good that you brought it up. So let's talk it. But this will be anyways covered in one of the slides. In computing, resources are basically 2 things: CPU and memory. CPU and memory. Okay. But there is one more point which I'll be explaining later. But let's talk about it. So just answer a small question, okay? When you what do you call fill the gas in your car, what is the unit you ask for? What is the unit that is there? Gallons?
Yeah.
Okay. Similarly, when you buy ice cream, maybe scoops is a unit.
Yeah.
Very similarly, when resources are asked, the unit of resource, it's called as container. So container is nothing but some CPU plus some memory. It's called container. So just to reiterate here, when it says two resources, that means give me two containers. Give me two containers. Okay. So basically, resources is nothing but CPU and memory, and unit of resource is called as container. So just I'll be reiterating the same diagram that once we do MapReduce, that's where I'll be explaining that these resources are nothing but they're called as containers. They are called as containers. Yeah. Next question. Yeah.
Okay.
So what is the second question?
Next question is, like you said, you're getting data from Facebook for the analysis that you mentioned. Now you are getting the data. The replication process, does it happen at the storage level or during the processing? Three times replication.
Absolutely during the storage level itself. When the data is written, that itself is replicated.
So isn't it? I mean, is it dropped? Because I'm just thinking that it's creating a lot of duplication, right? It's replicating three times. So if it is like I have 1 GB of data, it's replicating thrice. So isn't it extra usage of space?
Yeah, but the flip side or the better side of it is that you are able to replicate the data, because if you lose that data, then what happens? So you want to be sure that your data is there. That's precisely what, let's say we have DR sites in our organization everywhere, right? That if one thing goes down, you always have a fallback plan. And in a distributed system, it becomes more so important. Let's understand this. Okay? In Facebook, let's say you got 640 MB. What if only one machine goes down? You lose one block, your data becomes unusable, correct?
Right.
So the replication is very important, because one piece going down should not bring the whole system down. If replication was only one, the whole thing will come down because one block went down, the file is incomplete and we are in a mess. So that's where you require replication. That's where you require replication.
Basically, the replicated data stays in the storage.
Exactly.
Okay. Yeah. That's about it. Thank you.
Sure.
Okay.
Please go ahead.
Next person is Rajat Gupta. Rajat Gupta.
Yeah, hi, Rajat.
Hi, Ravi. Good morning. I have a question related to your where you have explained yarn. Can you please go to that slide?
Yeah.
Okay. Yeah. Here you said like yarn asked Mr. AppMaster, and then Mr. AppMaster allocates tasks or like asks for slaves to work on. So Mr. AppMaster is like, it's getting allocated dynamically, or Mr. AppMaster, like, it resides on some particular slave, like, how exactly it works. For Mr. AppMaster, you mean to say like MapReduce or Spark?
So AppMaster gets allocated dynamically, and it is not always running. It gets initialized only when the job comes, and the yarn will know which AppMaster to call, MapReduce or what you call Spark. So let me just give you an example. Let's just say that in your organization you joined in a capacity of a project manager. Let's just say that, okay? And you are project manager in web operations. So your organization gets what you call a project, okay, which is in web. Right now you are unallocated, so they will first allocate you. So then you are an app master. So your organization comes and says, okay, dude, you are the project manager. Now tell me, for executing this project, what resources are required, and then you will ask for all the resources, get the job done, and that's where the project will end. So think of App Master as a project manager for that particular project, and he's assigned to that project only while the project is running. Once the project is over, you are not assigned technically to any project. Now, organization in its pool will know that, okay, this guy is a manager for, or he's a skilled guy on the web. They will not give you, let's say, a project on administration side. You see my point? So you as a project manager are an app master. Correct?
Mm-hmm.
Yeah. And it's completely dynamic.
Okay. Thank you.
Yes.
Okay.
Question?
Okay. The next question is Sharma. Sharma, you are in the air. You can speak.
Yes, hi, Ravi. If you go back to that slide of 128 MB, the master and thing, yeah.
Yeah.
So in this one, like if you have this file for Facebook of 640 MB and 128 MB, I thought only it's going to be divided among only the slave nodes, but you're divided into just taken the 5 nodes, and that's how you have divided 640 by 5 to come at 128 MB, is it?
No, it's the other way. The file is 640 MB and each block will be 128 MB irrespective of the slaves. If there were only 2 slaves, we will still have 15 blocks. 7 will go to one guy, 8 will go to other guy. If there were 5 slaves, each one may get 3, 3, 3, 3, 3. If there were 10 slaves, some 5s will get 2 blocks and another 5 will get, let's say, 1 block each. Are you getting it? So it is not on the number of slaves, it is size of the file divided by 128. You get, let's say, 5 blocks. And now 5 multiplied by 315 are to be distributed among 4 slaves. That's the idea.
Okay. Okay.
So the block size remains constant, which is 120 MB.
Okay.
Yeah.
All right. Okay. Sure. Thank you.
Okay. The next person is Raghavendra Kumar.
Yeah.
Raghavendra.
Yeah.
Yes. Go ahead.
Yeah. Hi, Ravi. I mean, thanks for the wonderful session so far. So my question is for Hadoop 2.0. So when Yarn master allocate the task to the say app master, and suppose the task is in process and app master dies, then what happens?
So think of it from organization perspective. If the project manager leaves, what happens? The organization will have another project manager. Now, it's into the detailing of administration side, but just for the information, the resource manager will try 2 more project managers. So failure 1, it will try another project manager. Failure 2. If the other app master, second app master that has started, even that fails, then the job will fail, saying that resource manager tried twice to run this job, but we were not able to make sure that the app master stays up, so the job is failing. Then you're supposed to resubmit the job.
Okay, so you mean it is tried 3 times?
2 times, 2 times.
2 times.
Yeah, by default, the default number is 2 times. Your admin can always increase it. But at 2 times, it's a good enough signal that there is something wrong in your machine, that, your cluster, that machines are failing left, right, center probably, or a couple of machines have failed. So it's time that before you run your job, just go fix that and then resubmit the job. But you're free to make it 4 also, but the default setting is 2. That's an admin part, but yeah, the default setting is 2.
Oh, thank you.
Any other question, guys? Yeah.
Yeah, hi, Ravi. Just a quick question on this. So, as you said, right, the word movie is not it's not completely gone into one block. So that's why up to MO it went into block 1, and V onwards it went into the block 2. My question was like block 1 went on to the slave 1, block 2 went on to slave 2, for example. Then how a mapper, because when I say mapper, it is a single thread. So how a mapper communicates onto both the slaves to process both the blocks, because it's not logically split properly.
No, it's not processing the block. It's not processing. It's copying the data here. It's not processing that. It's just copying that particular piece of data and gets that information from the name node as to where is the other block available, and it basically then just copies that data temporarily.
Okay, if I want to read it back in that case.
Read it back in the sense. See, it's a program that's doing it. Data is already there, and it's a program that's temporarily reading it, finishing the processing, and then the data is still there only. It is just buffering that particular piece and processing it basically.
Okay, because why I was confused because if you see in the word count example, in this case, if it is on the block one, like block one on slave one and block two on slave two, how my word movie is as an entire word identified? Like, is it
No, it's not movie. No, no, it's the whole thing till /n. So the delimiter by default in text format is /n. So it is reading VI, and it was a lovely movie /n.
Okay.
/n is the identifier that till here we will go basically.
Okay. Yeah.
Hi, Ravi. Good evening. My name is Abu.
Yeah, hi, Abu.
Yes, my question is about the name node. So you said that there is a name node, and which, as I understand, based on an Oracle perspective, that name node, there is another standby name node, right? So
yes.
which is the copy of the name node. How about another a secondary name node? What is it the same? It contains the same copy of the primary name node. I mean, can you explain to me? Because high availability architecture, you said there is standby, then another name node. Yeah.
Now that's not the case. There are two different architectures. Okay. So let me just go back to this diagram, and let's just say that they are completely different. So old way, this is like old, and actually in real world it's called as classic mode. So when people will use they'll say name node is configured in classic mode, and this is called as so they are completely different. In classic mode, secondary name node is just a backup. Okay, think of it this way. In classic mode, if name node goes down, let's take a small quick story to this complete. Let's say night 2 o'clock in classic mode, the name node goes down. I will call Abu and say, hey man, name node is down. Abu will have to rush to his office because the system is technically down. Because secondary name node can never be promoted as name node. He will have to bring a new name node up and copy the data. So this was old mode. In the new mode, if night 2 o'clock I call and say, hey Abu, one name node is down, you will say relax and morning we'll figure it out because right now standby is running. Are you getting it? So there are two different modes.
Okay.
Yes, they are basically two different modes. They are two different things. They're not same.
Okay. So I have Vaishnavi with me. Vaishnavi, please go ahead.
How the blocks are split.
Yeah.
So if I have, do you have any echo? Please let me know if you have any echo. No, okay, good. Okay, if my .json file is only 50 MB, it's stored on only one node and duplicated, right?
Correct.
Okay. If I have like 5 nodes, if I have 5 nodes and I want the cluster to be 5 nodes plus 2 more nodes as a buffer, I want to just add 2 more nodes to the cluster, but I don't want to use them until I reach 90% of capacity on my 5 nodes, and then I want it to be expanded to 2 more nodes I added as a standby. Do we have such kind of concept in this cluster?
No, resource isolation is not there. You're talking of resource isolation, that's not there. So in Hadoop, I don't even have a facility where I say, I'm submitting this job, and you know what, use this set of 10 nodes and not this set of, that facility is not there. So I get that a lot of systems have resource isolation. Here you don't have that.
Okay, so MR is in command. So whatever MR does is what we need to accept. Okay.
Exactly.
Yeah. So Hadoop is, from the first slide I understood, it's storing and processing. So, but yesterday's class, I understood we can use it for OLTP as well, transaction processing as well. So, how can we really leverage as directly can I leverage Hadoop as is, or do I need something else to be involved to use it for OLTP?
No, I don't think anybody can make a claim that Hadoop is a OLTP system. If you mean OLTP by transaction processing, okay. Now,
right.
no, that's so. Let's understand that what. So sometimes terms get. So Hadoop is HDFS plus MapReduce or Map HDFS and Yarn. Okay.
Mm-hmm.
Now there's another system called HBase, which is actually you can think of it. Yes, it's a NoSQL database. It's a proper database which uses HDFS plus DB engine. But okay, so yes, it's a NoSQL database, but it cannot be used for OLTP. So if you mean OLTP is just RDBMS, yes, you can use it. But will you do hardcore transactions and all that? Transactions are not possible. So any RDBMS kind of activity that does not involve transactions can be done in HBase. Take a simple example, Twitter. Okay. Take a simple example, Facebook messaging. These kind of use cases where data is huge, but they are not transactional in nature, HBase can be used. But it's when you say OLTP, it's not ACID compliant, where I can't have transactions and commit and rollback kind of a thing. That's all.
Right. Okay. And
so it's a database, agree, but it's if you mean OLTP from the bookish term, no, it's not OLTP. OLTP. That's the point.
Right. Okay, understood. So is it purely for OLAP processing? Okay.
No, it is OLTP in a way, but can I directly say replace Oracle with HBase? No, because I don't have transactions, so I can use it as an OLTP minus the transaction facility.
Right.
That means I can't have commits and rollbacks. What I can have is any use cases which does like banking. HBase cannot be used for banking. But can HBase be used for a Facebook or any other thing like, for example, Flickr, Picasa, and all that stuff? Yes, it uses it. But they're not, if you see, they're not purely transactional systems. That's the idea.
Okay. So you will be covering HBase later on, right?
Yes, there'll be introduction in this course.
Okay. So will client connect to slave directly, or it has to pass through the name node always?
It just gets the references from the name node, but does not really, the data does not pass through that. The data does not.
Yeah. So basically, my connection has to pass through the name node always to go to the client. To go to the slave. Sorry.
That's all. Think of it this way, okay? Let's just take a simple context of it, okay? Let's say in Bay Area, okay, you would have, let's just take example of McDonald's. There are some 50 McDonald's stores, but there'll be only one phone number where you will call. So you call the phone number, place your order. Now that guy will place the order to the correct store which is nearest to your house, and that guy will deliver the order for you. Are you getting my point? So what I'm trying to say is the point of contact is call center. Yes, I agree. But all the job is not done through call center. Burgers or donuts or anything is made by the store, not by the call center guy. You see my point? So think of name node as your point of contact, agree, but data does not pass through that. That's the point.
Right. Okay. Yeah, I think that answers my question. I think I heard it wrong while you were telling me. Okay. So you mentioned about MapReduce in MapR2. We have MapReduce, Spark, and others. Apart from Spark, can you name like something else that I can replace instead of Spark?
So you can use Impala. No, okay. See, MapReduce is there, Spark is there, and then there is Impala. But Impala and Spark are not replaceable. Think of MapReduce and Spark are head-to-head, you can say, replacement of each other. And there is no third framework so far which is like a real, you can say, contender to be there. But Impala is a SQL engine which can run on top of Yarn, but that's about it. If you see, majorly there are two contenders, MapReduce and Spark.
Spark, okay. So Impala is also Apache product?
It is developed by Cloudera, which was later open sourced to Apache, yes.
Okay.
It was created at Cloudera.
Okay. So if my app master fails, the node fails, and it's already processing some job, MapReduce job. So will my job restart from scratch?
No, the job will not restart from scratch. All the tasks, what you call statuses, are written in HDFS, and the task will be taken from the same state only. It won't resubmit the whole job.
It won't resubmit. Okay. Yeah, I think that's all I have. And one more question. Do I really need to have minimum of 5 nodes to do any simple processing?
Not at all. I mean, you can have in this lab itself, you are going to do all your thing on a single node machine also. So Hadoop can be done on one node to two node to any number of nodes. It's not minimum 5 nodes as such.
Okay, got you. Okay, yeah, that makes sense. Okay, yeah, thank you so much. That's good explanation, examples, and drawing. Thank you so much.
Thank you. Thanks. Yeah, thanks a lot. Yes, Deepak, we had one more question. Deepak.
So we are on the Hima. Please go ahead and guys, I'll take the next question moving forward. So Hima, please go ahead with your question.
Hi Ravi, this is Hima. I had a question regarding the secondary node. Like you said, when the name node goes down, it's in the classic node actually. The name node goes down, you said we need to rush back to the office and create a new name node. So when will the secondary name node come into the picture?
See, secondary name node is just a backup of it. See, I'll give you a classical example of this. So think of it this way. I'm sure you would be reporting to some manager in your office. If that manager leaves, will they make you the manager? Probably not. So you know everything that your manager does, but probably you are not in line for manager. They may hire a new manager and you will just hand over or explain what your manager used to do. So secondary name node is just a backup. When it comes to standby, think of it this way, that if your manager leaves, you are immediately the manager next moment. That is called standby. So secondary name node is important because it takes the backup, but it is not in line of becoming a name node. So Mr. Secondary name node knows everything that name node is doing, but as per the design, it was never automatically promoted as name node. Are you seeing my point?
So the secondary name node will take the backup from the name node, and when the new name node comes, so the secondary name node will give the data back to the name node.
Absolutely, but my friend, the point here is the admin has to do that. See, you're right. Just that when I say night 2 o'clock, hey, name node has failed. Now admin has to rush to office, start a new name node from 0. And before he does that, he has to basically run a copy command from secondary name node to put all the metadata in name node and restart the name node.
Okay, yeah, I got it.
Think of it this way. Secondary name node has all that, think of it like the whole movie is with secondary name node, but secondary name node cannot play the movie. So the admin will come, start a new DVD player, put the DVD there and play the movie in the new name node, because secondary name node has no brain to play the movie. It is a backup. It's not a player.
Okay. So the admin will put back the data from the secondary name node into the...
Exactly. Right? Absolutely.
Okay. And I have one more question regarding the yarn. Like you said, the yarn reaches out to the MR app master for MR jobs. So this is only for the MapReduce jobs, right? The MR app master.
Absolutely. See,
and what about the jobs?
When the job is Spark, it will call in as Spark app master.
Okay.
So it will initialize a Spark app master. Based on the job that comes, yarn will know which guy I should call. As I give you a clear example, right? Let's say you are expert in web domain. Mainframe project will never come to you. You are a project manager for web. The organization will get you in the meeting only if the project is related to web. If it is related to mainframe, they will call the mainframe guy. If it's related to, let's say, administration, they'll call the admin guy. So your organization, who's a resource manager, based on the nature of the job, will call the right app master and say, okay, there is a job for you. Why don't you initialize yourself and tell me what you need so that the job can be done?
Yeah.
Are you getting it? Yeah. So Yarn has that knowledge of, I have to call this guy because this is the job. Yeah.
Yeah. Thanks, Ravi.
Sure.
Okay. So Ravi, let's move to the.
We understand how the data storage works. Data is broken into pieces and all that. But now the question is, how does MapReduce really work? Okay, guys. So it's a very simple concept. Yeah, books. A lot of people around, when you read a lot of blogs, would try to complicate it. Well, it's important to complicate because that's how people make money, right? So it's very simple. So just focus on the example, focus on the story, and we are done. Just focus on the story, and MapReduce will be done. It is one of the simplest thing that you would have heard, or you would be learning today. People would make big things about MapReduce, but it is that simple. So just focus on the example, my friends, and we are done. Just focus on the example. All I need is your attention for next 30 minutes, and we are done with the day. Then we can take up all the questions. Focus. Tighten your seatbelts and focus. So we understand that data storage works. We've had a lot of questions on HDFS, and everybody's clear. MapReduce is processing, but if I was a student, I would ask one thing to myself: what nonsense? Blocks are broken, data is individually getting processed, but somewhere it has to consolidate, right? How will that work? Who will do that? That is where you have to understand the concept of MapReduce. That somewhere data is broken, but boss, somebody has to consolidate. How will that work? And that's what we are going to see right now. So it's going to be very simple. Just pay attention, it will be done. Okay. All I need is your attention for next 25-30 minutes, and we are done with this topic. So let's say we have 4 guys. We have 4 guys. Ajay, Abhay, Amit, Abu. So these are 4 friends who work for an organization. Ajay, Abhay, Amit, and Abul. 4 guys are there who work for this organization, and their manager has told them that for next 1 year they are supposed to work on every Saturday and submit a report. Oh man, this is bad for them, right? So 4 guys, Ajay, Abhay, Amit, and Abul. 4 guys. These 4 guys are supposed to be in office for the next 1 year. Every Saturday they are supposed to come, and they are supposed to do some job, whatever, some report they have to generate, some XYZ report we don't care about, but they have to come to office. Now Saturday is a weekend, and you don't want everybody to waste the weekend. So these 4 friends, Ajay, Abhay, Amit, and Abul, what they do is they say that let's have a small deal that let's come at 8 o'clock in the morning. Let's work till 10 o'clock. Let's work from 8 o'clock to 10 o'clock. And 10 o'clock, one guy will stay back and consolidate the whole thing. One guy will stay back and consolidate the whole thing. So that not everybody is wasting the whole weekend, right? I mean, we'll come for 2 hours, and then every week we will take turns. Like week 1, Ajay may stay back. Week 2, Abhay will stay back. Week 3, Amit will stay back. Week 4, Abul will stay back. So that's fine. Let's do that. So it is this Saturday, early morning, 8 o'clock. Ajay, Abhay, Amit, and Abul, all 4 are in office. And from 8 o'clock, they start working. 8, 9, 10. Everybody is done with their work. 8, 9, 10. 10 o'clock, everybody is done with his work. And this week, Amit is supposed to stay back. This week, Amit is supposed to stay back. Okay. So, all of them will hand over work to Amit. Amit will consolidate and give the output. My friends, this is MapReduce. Nothing big. MapReduce is so very near real to what our life looks like, how consolidation looks like. 8 o'clock to 10 o'clock, when people are minding their own business, that phase is called as map phase. Whenever you hear map, that means mind your business. That means you are not looking at the left how many people are there, you're not looking at right how many people are there. You are just doing your job. That is map. At 10 o'clock, everybody is done with the work. And when you push everything to Amit, that is called shuffle. And Amit will consolidate everything. Don't worry how that works. that is sort. And finally, Amit will do the whole thing. We will see what is sort, and that is called reduce. So my friends, all I want you to remember one thing about MapReduce is MapReduce people will make it very, very tough, but it is divide and conquer. All you should know is map means divide, reduce means conquer. Map, divide, reduce, conquer. Map, divide, reduce, conquer. Okay. All right. Let's take one more example and we will really simplify it. Okay. Let's take one example. So I want a number of students from each country. Okay. Now let's say all student details are in a file of 189 MB. That's fine. I don't know the size. You also don't know the size. Let's have it 189. So I'm putting 189. You're free to choose your number. That's fine. One thing is sure that with 189 MB, there'll be two HDFS blocks. How many blocks? Two HDFS blocks. 128 MB and 61 MB. Now in map phase, we will have two mappers. How many mappers? Two mappers. Now the way map works is it will take one student at a time and basically process it. I'm supposed to find students by country. So the mapper output will look like some students will be here, some students will be here. Because mapper will take one record at a time and process it and give the output. So our mind your business phase is over where two blocks were minding their business without knowing what is happening on the other machine. They were only interested in what is happening on their machine. They were looking at one record at a time. That's how mapper is coded. Okay, life is good. After this is done, there is a reduce machine and everything should go here. So the act of throwing data here, oh, this is called shuffle. But my friends, before reduce can start, we need to create something called as groups or bags. And here there will be 5 groups created. Let's see how the groups will look like. China, C, D, okay, so it will be India, Malaysia, RST. Sorry, I'm not good at ABCD. This phase of creating bags is called as sort. And finally, reducer will take one bag at a time and say China 30, India 30, Malaysia 20, Singapore 10, Thailand 10. You've been doing MapReduce since the very beginning of your career. Let's look at this. Now, the previous example that I saw, can I say this was nothing but select country, comma, count of star from students table, group by country. If you really see there were 3 students or there were 100 students, how will it go through? The RDBMS will find a way to go through each and every record. Okay. So eventually there is loop where scans each and every record. Then if the bag is created, if the group is created, insert in the group, else create the group. Don't worry, it's simple. And finally, for each group, perform count. Is not created. Think of it this way now. Even RDBMS will go through each and every record. Now, let's say first it finds India. First it finds India. Is India group created? No. Sorry. If the group is created, insert, create the group and insert it. Okay. So scan each and every record. If the group is created, insert in the group, else create the group and insert it. So let's see how it looks like now. First, it looks at India. Is India group created? No. So create a group and insert within India. Okay. So like this, it will insert, finally have India, China and all. So the bags will eventually look like, here each and every record is scanned and here the bags will look like, the groups will look like China, India, and finally here for each bag you will say China 30, India 30, blah blah blah. Now let's phase it out. Going through each and every record, it's called map phase. Going through each and every record, it's called map phase. Putting everything in group, creating bags, it's shuffle and sort. And finally, performing the count or performing the aggregation. Reducer. This is MapReduce for you. It is that simple. It is that simple. Now, questions only pertaining to MapReduce, guys. So we have next 5 minutes before you can ask questions so that I can move to the next thing. So if you're clear with this, we are done with MapReduce. There are 2 more small details which I will add and we will be looking at the code. But that's MapReduce for you. So we are open for questions for not more than 5 minutes. And yeah, requesting sticking to the MapReduce would be great because new students or somebody who's worked on it, your questions may be advanced, but that will divert the new or they'll confuse the new students. So let's stick to this topic and let's talk of any questions that you have in the concept. Go ahead, guys.
Okay, so the question from the Kailash is how does it relate to real-time use case?
How does it relate to real-time use case? Everything, every kind of analysis that you do, any kind of querying that you do, it has to do now. Okay, let's put it this way. Let me simplify this a bit. Okay, looks to be a select query, right? So why can't I use Oracle? The point is that if your data is more small, use traditional tools. Problem is that how would you do this kind of stuff on a scale of, let's say, 2 petabytes of data? Okay, 2 petabytes of data. That's where you require map, shuffle, and sort and reduce. So just to in short answer this, if you're talking of how does it relate to real world, well, in real world, MapReduce is of no use at all if your data fits in a single server. MapReduce as a concept was created by Google because the data it had simply won't adhere to a single machine dynamics and mathematics. And today, most organizations are moving to big data because single machine dynamics are no more there. So what I'm trying to really say is that MapReduce as a concept, there is nothing new at all. Okay, that's precisely what I said in the beginning. It's dead simple and there is nothing new. Hadoop itself, there is nothing new in the concept other than the fact that now you can do things at scale. So if I was to oversimplify myself, let's first understand. So let's understand. So guys, first thing, anybody who is approaching this concept feeling that it's a rocket science, trust me, there is not even one thing in Hadoop that you've not already seen. Okay, not even one thing. In case if you find something in Hadoop that is absolutely nowhere there and only in Hadoop, show it to me also because I'll be really interested. The point is, everything that you do or you've been doing in past 10 years, 15 years, 5 years, 4 years of your career, everything remains same, just that now you do it in scale. So if you ask me use case of MapReduce, well, all the use cases that you see around are use cases of Hadoop, provided you have data. So while I explain, I will require a couple of questions to be answered from you so that we are on the same page. Can you unmute yourself, Shyam?
Hi, Ravi. Yeah.
Okay, Shyam. So simple question, okay? Now there are two guys who are doing Mapper. They are doing their own business. We want to consolidate it at some stage, right?
Right.
So that the process of first bringing everything together is called as shuffle. At least that part is clear.
Okay. Yep.
Correct? At least that part is clear. Okay. Now what is sort? See, data is coming as India, China, Malaysia, Singapore, Thailand, but my operation has to be done on a group level. So just grouping that data, not aggregating, just grouping that data together is called as sort. Okay, that's shuffle.
Okay, so shuffle is like we are pushing the data to the reducer. That's it.
Exactly. It's pushing, just pushing, no intelligence, just push it. And sort means group it together so that operations can be performed on that particular group. So I have a question now, just to ensure that we are clear. So this question is to everybody. You can put it on chat. Probably I'm not able to see. So Divakar, you can monitor the chat, and Deepak, you can monitor the chat and tell me if everybody is getting it right. In a function, I want to count the number of males and number of females. Can somebody tell me how many buckets will be created in sort phase? If you get this answer wrong, we are in trouble. In a group, in a function that is happening, I want to count the number of male attendees and number of female attendees. Can you tell me in shuffle and sort, how many groups will be created in the sort phase? If your answer is anything other than 2, we are in trouble. So please put it on chat. Is there anyone who's put it does not agree to 2, then we'll have to discuss. But if you got 2 right, then we are on the same page. Why? Because we wanted everything to be aggregated on males and females, so there will be 2 groups. Is everybody getting the right answer?
Yes, it will be like a group by only 2 columns.
Absolutely. 2 values, not columns values. No, that's not possible because they are running on individual machine and they will have their demarcation that is defined by the app master that this is what you're supposed to do, and that will not be possible because they are on different machines.
Okay, so
it's like each mapper or reducer task is its own JVM and it's basically processing its own block. So that conflict will not occur, and all that is basically intelligence built in the framework to ensure that.
Santosh, do you have any questions?
Before I proceed, I want to be sure everybody is getting it right. So please help me out with this answer. So there is a question for everybody. Just put it in chat and okay. And Deepak, I have shared the answer with you. Anybody is getting answer different than this, then we need to have a discussion. Guys, put it on chat.
I think everyone is good. I can see the right answer from everyone.
Perfect. Perfect.
So I have.
So if your answer is 4, congratulations, guys. You mastered level 1 of MapReduce. If your answer is 4, congrats. You are ready for level 2. And if your answer is not 4, then we need to go out for coffee. Okay. All right. Okay, my friends. Now.
Yeah, hi Ravi.
Yeah, please go ahead.
Yeah, you can ask. You can hear me, right?
Yes, absolutely. Please go ahead.
Okay. So the question is, I have a couple of questions that I think they missed my question on the chat, but I will be asking a 3 question. I don't know if you can answer those questions right now. So the first question regarding the mapping and the reducer. So what I understand that whatever block slaves are there, map and who the reducer and who designate the reducer.
That's exactly what I'll be showing in the next diagram. So that's exactly what will be answered in the next thing.
Okay, and there is one more question that is regarding the previous topic. That you mentioned that replication is happening from master to slave, and master is holding a metadata and slave having the data that is scattered on the different nodes, right? So my question is, those environment can be set up only the local network or we can do on the WAN network? the database server will be on the WAN and the Hadoop will be on the same zone, or it can be on the different networks.
Okay. In practice, in real world, everything has to be within the same network. So think of it this way: it's like your warehouse, which is not actually exposed to the web. So it will be basically within your firewall in the same network, preferably in the same subnet, because communication will become easier and maintaining control will become easier. So people will prefer the same subnet basically.
Okay, so it's a preferable setup that we can have a same LAN network.
But you are free to change that because everything is IP based. But the more you distribute in terms of, let's say, can I have bunch of machines in San Francisco and bunch of machines in New York? Well, of course, just that you will have a penalty of, when the data is broken, that communication will be penalty. Yeah.
Okay. Sorry, I have one more last question. We can set up those environments in VMware, or we need to have physical server for that?
Or you mean to say the virtual infrastructure?
The Hadoop infrastructure. We can set up in the virtual environment of VMware, or we need to have the physical machine for all those?
Okay. Actually, excellent question, but it's part of the admin side, but I'll answer it. Just that it's an interesting question to look at. Okay. All right, my friends. Now, first understand, can I go for virtualization? Very good for POC, not good for production. Let's understand. Hadoop's real USP is local processing. And in virtualized environment, there is no way to ensure local processing is happening. Second, Hadoop's other strength is replication factor is 3. But in virtualization, there is no way to ensure that the 3 virtual machines I'm seeing, are they on the same underlying infrastructure or a different underlying infrastructure? Third things, so if you look at a lot of tests performed, especially by Cloudera, because they have done a lot of work on this, in general, on average, they find that when you run something on virtualized environment, you get a 30% penalty on your yarn jobs because the data locality is not guaranteed. If you can think of it like all the analysis they have done, you should be prepared for a 30% penalty of performance if you're using virtualized platform. So for production workloads, it should be always dedicated machines. But for POCs, virtualization is a very, very good concept for POCs. Got it?
Yes. Go ahead.
Yeah, that's it. Okay. So Deepak, any other questions?
Not right now. Please go ahead to next topic.
Okay. So now let's come back to. So MapReduce, everything is clear. Only problem is, man, that this diagram somehow has serious limitation that all the data should go to the same reducer. What if that reducer does not have enough storage? Then we are in deep trouble. Then we are in a serious trouble. See, this diagram is excellent diagram, but with a limitation that all the data should go to the same reducer. Man, if in big data, if you're talking of a diagram like this, there are thousands of machines running, everything going to one reducer, everything will be dead. Right? So the point is, by default, the number of reducers in MapReduce program is 1, and you can change it, but you can change it. So if I wanted to have a load balancing, I could go for should go for 2 reducers. But then, if there are 2 reducers, my whole thing goes in a mess. Why it's a mess? How will I know what should go where? How will I know what should go where? And that is where a component just below the mapper is running, and that's called partitioner. Partitioner will decide which data should go where. So partitioner will ensure some data goes here and some data goes here. How it will decide, we'll see. So relax out. So partitioner may decide that, okay, China and India will go to reducer 1 and remaining 3 will go to reducer 2. Okay. And then here we will get China 30, India 30. And here I'll get Malaysia 20. Sorry. This auto suggest can really ruin your relationships. Singapore is 10, so it's 30, 80, yeah, and Thailand is 10. And then the developer can easily just run a merge command, which will just merge these two files, but the files are complete right now. So that is possible because of partitioner. Partitioner is a guy who load balances, but on what formula? Let's understand that. Partitioner uses a generic formula which says key dot hash code. Now hash code is, just don't worry, it's some integer. It is generated by JVM, Java Virtual Machine. So key dot hash code divide by, or modulo, not divide by, modulo number of reducers. Key dot hash code modulo number of reducers. So think of it this way. Let's say India dot hash code. Let's say it's not in my hand, it's not in your hand, so let's put any number. Let's say 80. China dot hash code 86. Malaysia dot hash code 71. Singapore dot hash code again 71. Who knows? Nobody knows, right? So neither am I in a position to tell what it is, and neither are you in a position. Thailand 79. So if you see, modulo 2 is 0, modulo 2 is 0, modulo 2, because the number of reducers are 2. Modulo 2 is 1, modulo 2 is 1. That's how it gets decided who will go where. That's what is done by hash code, partitioner. So partitioner by default works this way, and it is a guy who will basically load balance the whole thing. It will simply load balance the whole thing. It is as simple as that. Now, neither do you know hash code, neither do I know hash code. If everybody was having an even number, then everything would have gone to one reducer. That would have been a problem. Okay, so that's where a developer can come in and he can change this logic. He can write Java code to change this logic and say that, oh, I don't like this partitioner, I would like to have a different partitioner. So a developer can do that also. A developer can do that also. All right. So this is partitioner. Now there is one more last topic, combiner, but before that, my friends, let's open for questions. Let's be open for questions. Any question on partitioner? So you understood MapReduce. We've also understood partitioner. Please come up with questions, but let's stick to partitioner as questions because I just have one topic here that is combiner, and that will end. So let's hold on. Let's do one more topic quickly, small topic, and then we can take up questions on partitioners and combiners. So then we'll consolidate all the questions. Okay. Now What comes out of Mapper? So what comes out of Mapper is India one, China one, Malaysia one, and all that, and we are consolidating China and India. Why can't we do something like this? That we add everything up and we directly send India 22, China 22, Malaysia 6, Singapore 6, Thailand 6, let's say. And here itself we consolidate India to be 8, China 8, we know India, Malaysia 14, Singapore 6, and Thailand 4, Singapore 4. Now, instead of China and India like this, with combiner, we will get China 22,8, India 22,8. And here we'll get Malaysia to be 6,4, sorry, 6,14, 6,4, 6,4. And we get the consolidation. This is done by one guy sitting before the partitioner called as combiner. So that is combiner and partitioner. So that is combiner and partitioner. So now this kind of consolidates the entire MapReduce for us. We understand map, that is one record at a time. Then we understand partitioner, which is load balancer. But before load balancing, if you want to combine something, we can run a combiner, and then we do the reduce part. Okay. So
hi Ravi.
Yeah, it's right.
Are you able to hear me?
Oh, absolutely. Yes, yes. Can you hear me clearly?
Yeah. Actually, my question is this: like you say, the partitioner is like the normal load balancer architecture type of thing. Is there any my algorithm implemented at the partitioner level? Like if multiple job is running at the MapReduce level, then how partitioners decide which output of which job goes to which reducer?
That's exactly I have written right now, my friend. See, let's understand. This is the key algorithm, okay? Let's say the number of reducers are 4. Let's say let's say you have number of reducers as 6, okay?
Okay.
Hash code is any number, right? So any number modulo 6. Can you tell me the possible outcome? Any number that you know of modulo 6.
It's a 0, 1, 2, 3, 4, 5.
Exactly. So basically, this is the algorithm, which is key.hashcode. Hashcode can be any number. Any number modulo, let's say if there are 6 reducers, 6. Any number modulo 6. Either it is reducer 0, 1, 2, 3, 4, 5. That's the idea.
Mm-hmm. Okay.
Yeah, that's the algorithm.
Okay.
Yeah, hi Ravi, can you hear me?
Yeah, please tell me.
Yeah, can you go back to that map and reducer slide? I was having a question on this reducer, whether we can have a combination of reducers. Say, if I want to say that Malaysia or Singapore, this type whether I can do, or it will be a reducer depending on the different distance.
See, reducer, the instance can be one. There will be one Java code. Within that Java code, you can write if conditions. But there, the reducer code has to be same across the machines. Even the mapper code will be same. So I cannot say in the MapReduce program, 4 mappers do this, 5 mappers do that. That I can do it in a if condition within the code, but otherwise, no.
Okay. So let's say in this case, what you're finding that each country, right? So if I have a reducer, you can find out for both Malaysia and India if condition. So is it possible that?
Yes. That I'll have to write it inside the reducer saying that if country is India, only then do the count, otherwise don't do the count.
Okay. Okay.
Yeah. Oh no. So when you are submitting your code, that time you can define it. So let's put it this way. When do you define reducers or number of reducers? Now, admin has done it by default, but you can change it at runtime. So what I'm saying is, if you specify your setting wins else, admin setting. Got it, Shivali?
What if one of the node failed during the map phase?
Okay, that's simple. If one node fails during the map phase, the mapper will start on the other machine. Because there are 3 replications, it will keep on trying it. So that failover is taken care. That's the purpose of replication. So if one of the node fails while the job is running, as a developer, you won't even come to know because it will automatically start on another machine and it will succeed and everything will be fine. Yeah.
In performance point of view, does increasing number of the reducer increase performance?
Oh, yes, absolutely. Now, but the way to look at it is this, okay? There's a concept called, let's say, it's a slightly admin side of things, but let's just say that at one point, your cluster can run. So let me give you that calculation on a high level calculation. So now you decide for yourself, because let's understand the calculation and then you as a developer will be the best judge for it. Normally these settings will not be shared with the developers in a cluster, but I'm giving you the logic from the admin perspective, okay? In real world, this information or what you call numbers will not be shared with you. So this is like I'm giving an internal thing to you, but in real world you will have no access to it. That means that even if you know this logic, your admin is not going to tell you how many CPUs you have. Okay. So, but I'm just telling you how do you define it. So number of tasks that can run simultaneously on a machine is, let's say, number of CPUs minus 1. Number of CPUs minus 1. So let's just say that I have 100 machines and each machine has 16 CPUs. So here it is 16 CPUs minus 1. That means simultaneous tasks that can run would be, let's say, so you leave 750 for mappers and 750 for reducers. Okay. So now this, as I said, is of no use to you because here we are not factoring the other jobs that are running in the cluster. But if I'm just talking of only your job is running. Now, let's say if only your job is running. Okay. And if you say number of reducers is 758. Number of reducers is 758. That means there will be two waves of reducer execution. One with 750 and other with 8. So my point I'm trying to make is, what I'm trying to say is, let's come to your question. Yes, increasing number of reducers will definitely improve performance, but beyond a point, it may force another wave of execution. Okay, so all these details actually, guys, are of no use to you because admin is never going to tell you how many CPUs are there, and this calculation assumes that there is no other job running in the system. But the point I'm trying to drive home is, please increase your reducers, but there is no way to control second wave. If one wave is not available, second wave it will pass on, and that will have a performance penalty. So there is no direct way, as I said, to define the number of reducers if you don't know the data and the use case. Does that answer your question?
Yeah, like you said, like each reducer will produce a different set of output, right? Like, can we combine all the reducer output into one?
Oh, absolutely. Yes, there is a merge command for that. There is a merge command for that. That's a simple command. It's not this thing. So the command is, so don't worry about the command right now, but the command is get merge. Okay. Output, say part star into my final output. That's a simple thing. So don't even worry about it. You'll figure it out. It's fine. But
and each map reducer job is running in a separate node. That is correct. I mean, slave node.
That's what I'm showing in the next diagram. That's what I'm showing in the next diagram. Take up that to answer that. Okay, guys. So now here we come to MapReduce, and let's understand this. Okay, so I'm just answering your question only here. So this is okay, guys. So this is like the final diagram of the day. So today we are not able to do word count program. So let's do that next week. We'll jump into the code and go into details. Okay. So let's take up this diagram, and this will complete our MapReduce explanation. Okay, guys. So first, I submit my job data, which is 640 MB. That means there are 5 blocks. When I submit my job, automatically my number of mappers, because the blocks are 5, will typically be 5, and I can specify number of reducers. And let's say the number of reducers is, let's say it is 2. It is 2. So I submit my job. Number of mappers will be 5 because the blocks are 5, and number of reducer as a developer, I said I want 2. When I submit this job, AppMaster starts the job, and AppMaster tells so number of mappers is 5 and number of reducers is 2. When I submit my job, the AppMaster tells the yarn master that, listen, I will first start with the map phase. So please give me 5 resources. 5 resources. And now I am replacing this word resources with containers. It's called containers. So AppMaster says, hello, I will first do mapper phase. Give me 5 containers. Resource manager says, go take 10, man. Take 5, go enjoy. Now, after the map phase is completing, the AppMaster will go and say, hello, I need 2 containers for reducers, and you can give me on any machine, because anyways there'll be some traffic. So resource manager says, of course, take your container for reducer. So let's say one reducer will run here, other will run here. And after map is done, all the data is coming from all the machines. This is shuffle phase. And now the reducer will run and it will generate two output files. Output 1, output 2, which you can merge later. Okay, so this is mapping MapReduce to your cluster. Okay, so now just to iterate your question, mappers and reducers both will run on slaves only. First, app master will ask for mapper resources, then it will ask for reducer resources. Once it gets reducer resources, the data is then shuffled, sorted, and the reducer is run. Does that answer your question?
Yeah, thank you.
Yeah, so this is the diagram I wanted to show it at the end of explanation. So good, so we've covered that.
Hi Ravi, I think you have answered my question in the last explanation. Actually, I was also looking to understand where the reducer is running at.
Yeah, it is running on the slave only. Yeah. So this diagram I was holding till the last because after you understand MapReduce, this diagram makes perfect sense.
Okay.
Hi Ravi.
Yes, Pradeep, please tell me, Pradeep.
Yeah, Ravi, again, this is related to the thing that you answered just now. How is the reducers distributed across the slave nodes? If you say there are, for example, you took 750 each, right? So how would that distribution will also be managed by the master node, isn't it?
Absolutely, the app master. So basically, see, when it comes to reducer, for mapper, data locality is very important. But for reducer, wherever that is available, it will get consolidated there itself. So what it means is, when you submit your job, I can give you a vague idea. See, let's say if you're, for example, hey Ravi, I submit my job. Where will mapper run? I can say, man, 99% wherever the data is, mapper will run. Where the reducer will run, I will not know, because that wherever the capacity is free, reducer will run, because there will be some traffic either way. That's the idea.
Correct. So basically, based on the server load, both the mappers and the reducers will be distributed across the slave nodes.
No, my friend, that's important. That's exactly what I'm saying. Mappers mostly will run on the local node only because the data is locally available.
Okay.
But reducer will run wherever it is available because the consolidation can happen anywhere. Are you getting my point?
See, if a mapper runs on node 1, right? So it will take the data of node 1 and keeps it there.
Exactly.
So now the reducer, when it has, so if I have multiple nodes, node 1, 2, 3, 4, each mapper running on each node will take the data and hold it on the respective nodes.
It will hold the output on respective nodes till it notes where is the reducer running, correct?
Okay, so till mapper we are on the same page, correct?
Absolutely.
Now let us assume that we have 4 reducers also.
4 reducers, okay.
Now these reducers would be also distributed
on 4 machines, you're right.
Correct, on the 4 machines.
Yes,
and then they will work on the respective node and then bring it up for consolidation. Correct?
No, that's where the gap is.
For the final consolidation.
Exactly, but that's exactly where the small gap is. So let's understand. So till first 4 mappers, local data, perfect. Okay. So let's put some numbers, it will be right. Let's say there are, for example, just to simplify, that there are 4 countries. How many countries? 4 countries. India, China, Singapore, Thailand. India, China, Singapore, Thailand. When first the data was distributed during mapper phase, I don't know where the data is. So first node will do local, second will do local, third will do local, fourth will do local. Correct?
Correct.
Now all the mappers will tell the app master, Mr. App Master, mappers are done. App master will tell the mappers now that, okay boys, first machine will do China, second machine will do India, third machine will do Thailand, fourth machine will do, let's say Singapore. So he will tell machine number 1 that, dude, whatever you have China, give it to machine 1. Whatever you have India, go to machine 2. Whatever you have Thailand, go to machine 4. You understand the shuffling part. That means in the first phase, locality is important. In the second phase, the bucket has to be complete. That means if machine 4 has China data, then it will still pass it to machine 1. Are you seeing my point?
So that means one node will take the role of consolidation.
In this case, 4 are taking, right? Because there are 4 reducers. So how many output files will be there? 4 output files.
But then everything is giving to node 1, isn't it?
All China will go to node 1.
And then India will go to?
Node 2.
Can you put it on a diagram? It will be easy for me to understand. No, just just draw 4 boxes here. That's all. I don't need any major one. Not in this. Create a clean sheet. A new sheet.
Okay.
This will be too jumbled up.
Let's look at it.
Yeah.
Exactly.
Just 4 boxes. Simple. So we are clear on mapper. I want to see how the reducer happens.
So first tell me, let's say there are 5 mappers. How many mappers? 4 mappers. Let's say for your example.
4 mappers. 4 mappers.
Do you have control that? Correct. Do you have control that first mapper already will have all the data of India? No, right?
No, it will be working on node 1. So if node 1 has India data, it will have India information.
No, my friend. When the data is returned to Hadoop, how do you know what is going where? Nobody knows. Neither do you know, neither do I know.
Correct. But then,
correct. See, right now it's mapper phase. Correct. So right now nobody knows. Neither do you know, neither do I know. So let's just say that this guy has India, China, Singapore, and Thailand.
Okay.
Correct. Nobody knows. So neither do you know. I may be wrong. You may be wrong. But one thing is there. Nobody knows what data, what country's data it has. Correct.
Perfect.
So this is mapper phase where all these guys are having their own respective data.
One more thing, Ravi. What I understand, Hadoop will only replicate data thrice, right? So it will not be on 4 nodes. It will be on 3 nodes.
The data has 4 blocks, right? How many blocks does data have? No. Hold on. Oh, you're confused. See, leave the replication out right now, my friend. This is one big file with 4 countries. And just to simplify,
yes,
this is 512 MB.
Okay.
So this is 128 MB. This is 128 MB. So this is not replication. I'm not even talking of replication here because that will confuse matters more. So this is pure fresh data with no replication so far. So far good? Okay. So far good. Should I proceed?
Yeah.
Okay. Now mapper 1, whatever output it gives, it will still have information for all the 4 countries. Only mapper output. Correct?
Okay.
So whatever operation you are performing, so far we've not got to shuffle and sort. Now the app master will say, okay boys, all mappers done. Be careful now, reducers will start, and on machine 1, reducer for China will run.
Okay.
So this is reducer for China. Okay boys, reducer for China is here. Reducer for India should be here. Okay boys, reducer for Singapore is here, and reducer for Thailand is here.
Okay.
Now
so that means
all China will go here. China will go here. 1 minute. All China will go here, and China will go here.
Perfect. Subsequently, for others also will happen.
Exactly. So then all the Singapore will go here, Singapore will go here, Singapore will go here, Singapore will go here, and all the Thailand will go here, Thailand will go here, Thailand will go here, Thailand will go here. And now this file will have China output. This will have India output, Singapore output, and Thailand output. Yep. That's the deal.
Perfect.
Yeah. So this is how exactly it will work. This is exactly how it will work. Yeah.
Now, my other question is,
Yeah, go ahead, please.
you said that if you reduce the number of reducers, the processing will be fast. But I feel overall it will degrade because your processing power of mappers will reduce. Now, taking this example,
No, hold on. Relax. You're not quoting me correctly. Think of it, okay? I never said that reducing reducers will improve performance. No. What I'm saying is, no. See, hold on.
Increasing reducers will increase performance.
Yes, increasing reducers will increase performance.
But when you increase reducers, you reduce mappers, right? If I come to this example, you have 4 mappers and you have 4 reducers.
Okay, hold on, my friend. Can you define number of mappers? Yes or no? Can you decide number of mappers? Yes or no? First answer that.
Yes.
No, you can't. That's exactly what I said.
It will be based on your...
Exactly, it's size of the data. Now, imagine if the data was 512 terabyte, the mathematics of mappers will completely change. If this was 512 terabyte, it would have been 40,000 blocks. Correct?
Okay.
See, why there are 4 blocks right now in mapper? Can you first tell me that? Why it is only 4? Why it's 4 is perfect? Because the size is? No, the size is 512 MB. No, man, no. How do you know already how many countries are there? Nobody knows, right? It is
okay, this is 512 divided by 128.
Exactly. How will I before itself know 4? Nobody can predict the data, right? I mean, when I give you the data, how will you so accurately be knowing how much? See, 512 terabyte is the data. It will get broken into, let's say, 440,000 pieces. So it will be like that basically, nothing to do with the countries. See, when the data is coming in, we don't even know that our analysis is going to be on countries or cities or states. Correct?
Yeah.
Right? So for example, I say one big file with 4 countries, but boss, these countries may also have states. We've not even defined what analysis we are going to. So it is 512 is the factor. 512 is the factor. Nothing to do with countries at all.
So if I have 1 TB, so the number of mappers would be 1 TB divided by 128 MB. Is it?
Absolutely. Exactly. Now you have it.
But till now the examples which you all gave, where we selected 2 and all that, unfortunately I was thinking in terms of the example.
No. If you look at my example also, I was very careful in showing you the first example. If you carefully
look at missed out something. Okay, fine.
Look at this. There are 5 countries, but there are 2 blocks because the size of this is 189 MB.
Okay.
Because the size is 189, there are 5 countries. Still the mappers are 2. Why? Because 128 plus 61 makes it 189.
I got it.
Right.
Now this is clear. Exactly. Thanks, Ravi. I missed the basic. Okay.
Sure.
Hi, Ravi.
Yes, please tell me.
No, already I have got the answer from this explanation. Thank you.
Okay. Perfect.
Yeah.
And hi, Ravi. See, the application master, does it run on all the slave nodes or it's on any specific slave node?
Any one slave. One job will have only one app master and it will run on any one slave node which cannot be predicted.
Okay, it's again, application master is something like a dynamic, is it? It will. Oh. Okay, like if application master is running any job.
No, think of it this way. Application master is master for that particular program. It is master for that particular program. So when you submit a job, the resource manager will first look at the cluster and say, oh, you know what, machine number 3 is free. Let me run app master there. Then it will communicate with the app master and say, looking at the data, tell me what do you need. So the app master will then look at the requirement. So think of it this way. Your organization gives you a project. So first they look at you as the manager. So every project will have one manager, right? Now the organization will ask, okay, Mr. Manager, you are responsible for this project. Tell me what do you need? So as a manager, you will say, I need 4 developers, 2 testers, and 1, let's say, what you call HR guy, for example. Organization will give you that, and then you are responsible for success or failure of that particular project. So if there are 2 jobs running in the cluster, there'll be how many app masters? 2 app masters running. If there are 15 jobs running in the cluster, there are 15 app masters running. That's the idea.
Okay. Thank you. And can you please explain that role of combiner one more time? I just got confused between combiner and partitioner.
Combiner and partitioner. Okay. So let's take a simple example. Let's take the country example. I think that was exactly what we are talking about, right? Now, mapper can process how many records at a time at one shot? Mapper can process how many records at a time at one shot? At one point, it can
at one record at a time, right?
So that's why when mapper output would come, it will come as India 1, China 1, India 1, China 1, India 1, China 1. So this is how mapper will give output before sort. China 1, 1, 1, 1, 1, 1, 1. But if you carefully look at it, you will say, Ravi, there are 2 mappers. Why can't I consolidate India, China, Malaysia in the mapper level itself? So India 22, China 22, Malaysia 22, Singapore 22, Thailand 22. So combiner will consolidate. Partitioner will define who will go where. Combiner will do local processing. Are you getting it?
Yeah, got it.
That's the idea. That's the idea. Okay, guys. So yeah, any other questions also we can take up next week and this week. Okay. All right, guys. Have fun and thanks for joining in. I really enjoyed today's time with you guys. And next week let's catch up. Yeah. Thanks, guys.